So as we can see here, we got two sets, that is our set 0, 1 and our set 3, 5. So since there is no change between the two steps, step 1 and step 2, okay, so we will stop here. So we stop this process and then we combine the states 0, 1 and we combine the states 3 and 5. Okay, if you look at the definition, from the definition of equivalence, what does it say? It says delta of P on W, okay, and delta of Q on W, okay. If it gives the state R and R dash, then both R and R dash must either be non-final states or both R and R dash must be final states. So if we look at our one equivalence means the length of W must be equal to 1. So it is one input symbol. So if you look at this, delta of state 0 on input symbol 0 and delta of 1 on input symbol 0, what do we get? Delta of 0 on 0. So 0 on 0 goes to 1, goes to state 1, and 1 on 0 goes to 1 on 0 goes to 0, goes to 0. Okay, so state 1 and state 0 both are non-final states. Okay, same way if we take for the second, that is input symbol, that is 1. For 1 if we take, then also we get 0 or on 1, 0 on 1 goes to 3 and 1 on 1 also goes to 3. So this is 3 and 3. Now if it is the same symbol, it doesn't make any difference because it's going to the same symbol. And if you see, 3 is what? 3 is a final state. So both are final states. So we can say that state 0 and state 1 are one equivalent. These are one equivalent. One equivalent, right? So we can combine the two. The same logic also applies for 3 and 5. Now, if we combine this, let us write our transition table first, then we will draw it. So our first combination is 0 and 1, input symbol 0, input symbol 1. And the next is 3 and 5. So 0 and 1 on 0, 0 on 1 and on 0 will go to same, 0 will go to 1, 1 will go to 0, so it will go to the same 0, 1, and 0 and 1 on 1, 0 and 1 on 1 will both go to 3, so 3 is not there alone, so it will go to 3 and 5. Similarly, 3 and 5 will go to 3 and 5 on 3 on 0 goes to 5, 3 on 1 also goes to 5, and 5 on 0 goes to itself, and 1 also, at 1 also it goes to itself. So it goes to itself, 3 and 5. Okay, so our combined states would be 0, 1, 3 and 5. Which will be our start state? The start state the subset which contains the original start state, which was 0. So this will be our start state. Which will be a final state? The final state will be the one which contained the final state of the original. So 3 and 5. So this will be our final state. And what is the transition? On 1, 0 and 1 goes to this. On 0, it goes to itself. And 3 and 5, on both 0 and 1 goes to itself. So this is our minimal or the minimized DFA with two states. We started off with I think I had removed this. So we had started off with 5 states, and then we've started off with 6 states, and then we had reduced it to 2 states. So this is one way of the equivalence method of minimizing a DFA.